All right. Hello, everyone. I'm Pedro Barreto from Crosslake. And this presentation is to give you an update on the vNEXT build effort. So let's get started. Is this moving? No. Oh, it is. Right. Yeah. Okay, so this is the agenda. We'll start with the update on the reference architecture documentation status. We'll then proceed with a status update on the progress of the vNEXT build. And we'll finish, and this is going to be the majority of the session, with a few examples and a few details on how the foundation for vNEXT that we're building actually works. So regarding the reference architecture documentation. Oh, that's fine. Okay. That's okay. So last PI, we released the reference architecture documentation. And since then, we've been working on getting some fixes and improvements done. Michael Wagoner has been working hard on the review process and the fix process. We identified initially at least around 20 issues that we had to fix. Michael has been working in this. He's been fixing a lot of the snapshots that had didn't have a lot of quality on the diagrams. We now have good quality diagrams on the documentation. And he's likely chasing some of you guys to ask for help on review processes and some of the confirmations for the work he's done. So please, if you're one of those people, just respond to Michael as soon as you can. By the way, this is the link where the reference architecture document is sitting on. And this is how it looks. It adheres to the new format and the new style of the documentation that we have for module. Okay, on to the vNEXT build progress update. So for those who don't know, the vNEXT build initiative, as Simeon was explaining, is about building the next generation foundation for the modular platform and incorporates the learnings from the reference architecture and the design exercises that we had throughout the last 2 or 3 PIs. So before going into the actual status update, we need to recap what the phasing that we have. In this case, we are releasing as soon as possible the alpha release, and we need to recap what exactly this is. And apologies if you guys have been hearing this for pretty much all of the presentations that I do, but I have to keep on repeating it. So as you know, the reference architecture that we created a few PIs back is significantly different from the current architecture that we have in the current modular code base. It has the new versions or the new structures and the new design. They have significant structural differences from what we have today. And it's also an opportunity to increase the technical foundation of the platform. And this is what we're working on those hard to make structural changes that are not simply refactor. It's not easy to just pick up something that we have that is as extensive as the current code base and completely change it. It's sometimes not feasible. So once we have this technical foundation, we'll add the most important features that the current version has, targeting only the happy path. So essentially, this alpha release is not going to be a full working solution. It's just a happy path. So what we wanted to is we want enough functionality so it's relevant for comparison so that we can compare the vNEXT version with the current version that we have, and it looks the same, it's still the same platform. It must be fully testable and should prove the scalability of the design. And we are not going to be focusing on the optimizations, so we will leave those for later. But one of the items that I'd like to stress is, apologies, is the ability to fully test the code. So we're building this not exactly as a test-driven approach, but making sure that everything is extensively testable. And all of those components have to have or must have stable interfaces. And this is an important aspect because we want other developers and the community developers to be able to contribute as soon as possible without fear of refactors. So essentially, this alpha release is targeted for developers, and our objective is to get it done as soon as possible so that anyone that's interested in contributing has that stable foundation where they can start building against the foundation and building against those interfaces without fear of changes as we go through the beta and then in the future, the production version. So the expectation is that once we're done with the alpha release, we have plenty of community developers interested in starting to port current solutions, current implementations, and current integrations with the new version of the platform. So we had this built or this split into 3 phases. A design phase that comes from or is the continuation of the reference architecture work that we did with a lot of you. And essentially, this is just putting up the structures and the patterns and the principles in accordance to that reference architecture. So nothing special. We are doing what we say we should be doing. We picked up the reference architecture and we said, this is what we must implement. There's going to be technical differences, but the structure is the same, the patterns are the same, and the principles are the same. The building for the foundation and the cross-cutting concerns. And what are cross-cutting concerns? So these are the things that we have identified that are not necessarily specific to a certain part of the module. So they are not specific to participants, not specific to, for example, the transfers or the ledger part. Those are exactly cross-cutting concerns. So things that cross across the board and that we actually need to fix for everyone before starting to put the valuable code, like the transfers and the participants. And this includes things like the foundation, like the setting up of the repositories, the CI/CD pipelines, that boring stuff, but that it needs to be there. It's also that building of those cross-cutting concerns like logging, auditing, security, and some of that actually we are going to show in the latter stage of this presentation. So next, we're going to start working on the happy path code for the main use cases. And here is that part where we're going to bring the most important features of the current module loop implementation so that we can have a comparison, like-for-like comparison. And these are things like transfers, accounts, balances, and participant lifecycle management. Okay, so I keep complaining, I know, but we don't have enough resources. So due to the lack of resources dedicated to this build, we had to revise our objectives, and we keep doing so, but we are still making progress. So our objectives are to deliver the cross-cutting concerns during the month of May, and it looks like we're well headed to deliver that. Yeah, this is readable. Okay, so this is where we are against those objectives. We're progressing slower than expected, but we are making progress. And for those of you that looked at or attended the Meet PI review, this is a lot greener than it was before. So that's a good thing. All right. So this next part of presentation is going to be about how does it actually work. I noticed that we've been doing these presentations about the vNEXT and talking about cross-cutting concerns and the foundation, but I don't think everyone is aware of how exactly that works and what it means. These are going to be, I've tried to simplify these diagrams as much as possible, but I'm going to go through those diagrams with you. So this is platform configuration. Essentially, it's the central configuration management for the whole platform, for the whole module loop platform. This is something that we didn't have we don't have in the current version, and we're investing in the vNEXT version. So essentially, it's a central configuration management tool. Sorry, let me just make this bigger. Apologies. So if you look at the left side, you will see that there's a bounded context A or application X. So this is essentially, it's the language that we've been using in the reference architecture. A bounded context is a business area of module loop. And we have identified a few like transfers, accounts and balances, participants. So it's essentially when you split up module loop into business functions as if they were departments on a company. And here what you see is you see application X, it's a certain application that is being built or being iterated. So as we have either the first version or a new version of an application, what we build in that application with a specific library that we are providing is you have the ability to bootstrap that application. So essentially, the first time this application gets deployed, it's bootstrapped against the platform. One of the things that happens during this bootstrap process is the sending of the configuration schema for that application. So essentially, that application is telling the platform configuration, in order to work properly, I have a bunch of configuration values, configuration parameters, and these are the types of the configuration parameters. They can be a parameter like a Boolean, a string, a number, for example. That schema includes a default value that should be implemented immediately upon the delivery of this configuration schema to the platform. And it also includes a description so that we can have it like a UI that can use this description so that we can provide a nice UI for operators to use. So at that point, that configuration schema is sent to the platform configuration service. That platform configuration is obviously going to validate and store the configuration schema. So at this moment, the common configuration management system knows that there's a certain application that belongs to a certain area of the system, a certain bounded context, and that this application needs a certain set of parameters to operate. And when I mean parameters, I'm not specifically talking about technical parameters. So these are not the things that we're typically passing at deployment time. These are optional things that decide or help the system know how to behave. So these are parameters, like business parameters, not necessarily little tweaks like timeouts and things like that. These are actual business parameters. So at this point, obviously, the platform configuration services are going to store that configuration after validating in a certain store. And I'm going to go to a point where I explain why the configuration store is separate in here. Usually, we put just the configuration store as part of it. It's assumed that we have a store. Anyway, so this is how it works. And this is the, I don't know, yeah, it's still readable. So this is the other side of the coin. So now we have, the operator now has the opportunity, or someone that has access to it, the operator has the opportunity to either directly through an API or through a nice UI where those descriptions can be seen and can be understood. The operator has the ability to change a parameter. So that change is going to be triggering to be sent down to an API, and that API is going to call the platform configuration bounded context. That platform configuration bounded context, it has a service, and that service is obviously going to validate the configuration and make sure that everything is all right and that value is acceptable. And once that is accepted, it's going to persist the new value, and it's going to send a trigger event. It's going to trigger an event. This event is important because the application that owns that configuration parameter will be listening to these events. So in this case, what the application is going to do is up to the application, but the application now has a chance of reacting to this change in parameters. Essentially, the application can decide either I have the ability to apply the new parameters and continue working, or I will need to, as simply as I'm going to restart. The application is restarting because there's new parameters, which means that the application restarts and suddenly you have the new parameters in place. So there's obviously other side benefits to this mechanism, which is because all of the business parameter changes go through this platform configuration management services. We now have auditing as a benefit, and we have full track of who did what to the system, when, and what was the conclusion. So this is another important part. We're getting the platform configuration in an easy to use way, and we're getting the auditing, and we actually can go back to a previous state. One of the other important aspects is that this is versioned. So every time that we update the parameters or the values of those parameters, we're generating a new version of the configuration for that application. So we can go back. So we know exactly how the application was running 2 years ago. So this is the operation. So this is the platform configuration perspective from an operator. So again, to sum it up, there's a service that controls this. There's an API that fronts this service. And obviously what we expect is that someone that has good visual skills will build a nice UI on top of this so that operators can use a UI and not necessarily the admin API. So this is what happens when an application is starting. So this is the other part of how does the application actually do this? So the application starts, and as soon as it's booting up in the process of starting the application, there's plenty of other stuff that's going to happen. I'm trying to simplify this as much as possible, but essentially what the application needs to do is the application already knows the default values. So it knows its default values. So if it cannot communicate with the platform configuration, there are good known values to be used. And at this moment, the application is starting, and it sends a message to the platform configuration services. And it says, I'm application X, I belong to a bounded context A, and I want to get my up-to-date values, my parameters. Then obviously, this is going to happen is there's going to be a validation and retrieval operation. And soon enough, the application is going to get the return configurations with those values. At this moment, the application has everything that it needs to start working normally. So what's not seen here is the reaction of the application to that triggered event. So whenever an operator changes, as the application is already working, already running, this is not showing that trigger event. Essentially, it's just the application is listening to a trigger. That trigger tells the application that it needs to reload or it needs to apply the new parameters. Again, the way we're delivering this is that the platform configuration VC has services that we're building, but it also has Node.js client libraries. So any application can just use that Node.js client library to bootstrap, to get the configurations, to create the parameters, create all of those things. So all of that is facilitated through a library application that's pretty easy to use so that application developers don't need to worry about this. Okay, so this is logging. And I have to explain or to start by explaining what logging is, because it's not obvious, or at least it's not obvious the difference between logging and auditing. So logging captures the details of how something happened, not the what, but the how. And this is a detailed view. For example, that a certain method was executed, a certain line of code was tapped through. Usually logs are only interesting for programmers and system operators. And now I will go into the next slides on the auditing, but logging in our case is just this. There's a certain set of criteria for logging. One of them is developers and operators will need it. They have different levels of logging. We're not going to be very sorry if we lose logs. It's just logs, it's just for programmers. So let me explain the progress, the process. So again, it works in the same logic. There's a central component that hides the storage mechanism, abstracts the storage mechanisms from the client and from the applications. And there's a client library to do the logging. So what we have is a logging component, a logging service that is able to receive requests to log, to create entries, either through an RPC call, like an HTTP call, a post, or to an event that gets sent through Kafka. Either way, those logs are going to be persisted and taken care. So on the left side, we have an application that is trying to log. So this application will again use or can benefit from that library, that Node.js library that we are providing, and essentially just configure that library, use that library, and then say, I want to log a certain thing. This is a debug log, this is an info log level, etc. Whatever the typical log operation requires. And it can pass values. Then those logs, those log entries are sent to the logging infrastructure, and the logging infrastructure, the central logging infrastructure, is going to make sure that that is persisted so that it can later be retrieved by an operator, by a developer, by someone. And on the right side of it, we are representing here the persistence layer, and this is likely to be today. Sorry, it's an ELK or an equivalent log storage, just the same as we have. I'm going to take the opportunity of explaining here why we are doing all of these three things, because many of you are going to ask, why are we complicating things? Why are we not just logging from the application directly to ELK? And the answer is an important one, because we need that abstraction in the middle. We need the ability to make sure that to simplify on the left side, to simplify on the application, and to be consistent, we have to put the complexity in the middle. So what we're doing is we're offering that complexity in that service, in the logging VC, so that we can abstract two things. We can simplify the client So the client simply use a library or they send a certain message. They don't need to know a lot to be able to log centrally and benefit from all of the central logging mechanisms and functionality. And on the right side, we also have an abstraction layer that makes sure that that logging service, that logging mechanism is able to persist to different stores. And this is another benefit as well. We all know that every now and then we need to change a database or change a persistent store. And we know how difficult that is when we have software that is tightly coupled to an infrastructure implementation. This is one of the concerns that we have in vNEXT. We are not coupling anything with a specific infrastructure implementation. Everything that we use has an abstraction. So we are using the repository pattern and we are using aggregates, and we can discuss some of those details and actually see the code in a later stage during these days. But effectively, what we're doing is this: we are making sure that what we are building is not immediate technical debt, and we have these abstractions all over. So yeah, I explained this how it works. So obviously, the operator will have that ability to consult the log storage. So sorry, yes. So difference for auditing. Auditing is about who did what and when. This is a business problem usually. So what it means is that as someone outside, as an auditor or someone interested in knowing domain facts or events, something that happened in my system, why was it changed, for example? Why was the configuration changed and the system is running differently, for example? And why was a transaction approved or a participant renamed, for example? So all of these things are significant from the business perspective. So they are not mere logs that a programmer needs to look to see if the application is working well or not. These are business important things. So these are somehow, there are obviously some similarities with the implementation of the logs. You can see that this is pretty much the same thing. There are, however, some slight differences in this, which are the two things. So the first one is the security. Audits are signed, and audits are signed with two keys. The first key is an application key. Each application has a key, and when they submit a log entry, they will sign that log entry against one key, their private key. And then those entries are again sent to the audit bounded context. The auditing bounded context is going to sign it with its own key. So which means that at the time of storage, when we put those audit entries, we have them signed with two keys. And this is what assures that we are later not going to be able to change those things, those log entries. And another aspect that is important for this is that the auditing BC, or rather, no component in this system has access to change audits or to delete audits. The auditing store is write only, and this is an important aspect. So what it means is that it guarantees that the system has no ability to mess things up if it has a bug, and it has no ability for someone to overwrite log entries or just change them or do other nasty stuff. So essentially, the system is designed so that we are writing only, we don't update, which means that we can have the necessary enforcement in the store so that everything is just right. No one has access to change. And there's a difference, a significant difference between adding new data and overwriting data or changing data. So this is the auditing part. So this is scheduling. And again, another overlooked problem in distributed systems. How do we manage time and how do we manage things that need to happen in the future, especially in a resilient way? So this allows application, this service and its library allows applications to register time-based reminders centrally in a way that they can be resilient so that they can survive a failure in the client application. So it can be thought of as a resilient platform-wide cron job that actually is going to work if everything else goes down, and that's the objective. So a client application can register a reminder. Essentially, it can say, I need someone to send me an event with a certain payload to a certain topic in X time or with a certain frequency. And this is a definition that we can do, either a recurring event or a point in time or a certain amount of time in the future. And what the scheduling bounded context is going to do is it's going to store this information, and then when time comes, it's going to execute it. A few examples where this can be helpful. Imagine a process that needs to work or needs to be executed at a certain time of the month. So like a report, or every day, a certain time, like a settlement or something that needs to work to be executed on a time base. We don't want the application that is implementing that scenario, that activity, to be worried about how to implement a distributed cron that's resilient and that's performant. We don't want that. And this is why we created this facility. So this now is the other side of it. It's the, how do we trigger the reminder? And essentially what's going to happen is that sometime in the future, once that reminder is registered, it's going to be time to send the reminder. So at that moment, the scheduling bounded context is going to execute what the client asked it to be executed. Essentially, it's going to either send an HTTP call with a payload to the client application that is exposing an HTTP endpoint, or it's going to publish an event with a payload to the topic that was requested. All the application has to do is to know how to handle this. So because there's a payload and there's correlation IDs that can be used, when I'm requesting the reminder as an application, I can send an ID of something. I can say, this is a reminder for my daily settlement execution, which means that then the only thing I need to do to make sure that this is happening on time is I have to listen to a certain event. When that event comes, I'm going to look at the event, I'm going to open the event and see this is the daily settlement execution. So I'm going to kickstart that work. So again, I don't have to worry about cron and about distributed timekeeping in my application. I just have to react to events. And this is another simplification that is an important one, because we don't want everyone that needs time-based mechanisms to be implementing distributed crons. Okay, I saved the best for last. And apologies because I don't have the authorization flow. It wouldn't fit on a single slide. It's bigger, but I'm happy to show you how that works and demo how the code works if you'd like to. So a bit of an explanation. The security bounded context is doing a lot of the things that from the reference architecture, we also recognize that we didn't have. They were not built in modulo loop initially. And this is something that we're now taking care of. The security bounded context will have authorization and authentication mechanisms. It will have a mechanism, those identity and access management adapters and the KMS services. Essentially what those are again abstraction layers. What they allow us is to interact or interface with different mechanisms for identity and access management. So essentially we can interact with an Azure mechanism for a directory, like an Active Directory B2C, or we can use Novell. I don't think that's a thing anymore. We can use plenty of other mechanisms because we can have an adapter that allows us to abstract the security concerns from the inside. So again, we're doing the same thing. We don't need to implement specific things. We don't need to care for the external system because we have this layer that adapts between the external concern and the internal security concern. So what we have is an authentication service that behaves consistently to the applications inside the platform, so that those applications know exactly how everything works, how authentication is being performed with a common way that everyone can benefit from. And again, we have a library, a Node.js library that can be used to leverage the authentication and the authorization. And what's happening is that the security bounded context is going to hide the complexity of integrating security functions with external components. Things like identity access management, we don't care about those on the inside. Effectively, what we're going to do is we will have one adapter for each of the external concerns, and then the authentication service talks to the adapter that has been deployed with a common interface so that we can do logins in an external environment. What this means is that, for example, an operator can use its own login in an Active Directory environment in a bank and log in to the modular loop platform with its credentials. So the same can be said for the cryptographic functions and for the key management storage. It's the same mechanism. We can use an external secure hardware or not, but an external secure KMS performance provider or a crypto provider. That can be an HSM, for example. Again, the same is happening. The security authentication services are abstracting the usage of those components. So when we log in, when we ask for some authentication function, what's happening is that the authentication service is requesting that to an adapter, and the adapter is requesting that to the actual implementer of that function, which again means that we have this abstraction in the middle so that we can integrate pretty much with whatever we want, as long as we create the adapter for it. So we don't need to reinvent the wheel with a system like this. So how does this work process-wise? From the left, you will see an operator or, oh, sorry, this is a bug. This is not a, this was just a copy paste mistake. On the left, it's not IAM, internal or external. This is an application. So that, does this point? Yeah, so this is a bug of mine. Pretend this is an application. So this is an application and can be whatever application, an external application. It can be the transfers application, which, by the way, it's something that I forgot. Everything inside this new platform needs to be executed in a secure environment. So users and applications are treated the same. A user and an application needs to authenticate to all services. So applications need to have, when they start a private key, they will have a client ID and a client secret. With that, they will request a token to the security system, and that's only with that token, they can request access to other parts of the system. So it's exactly the same thing. Everything needs a security token, and I'll go through how you get that. This process that we're seeing here, and this is where this is going to be beneficial. So the login process, it's the exchange of my credentials, either I'm either a person or an application with that token. So what's going to happen is that this is going to use that stable interface, and it's going to ask the security services, this is my username, this is my password, please give me a token. And again, what's happening from the security bounded context to the right is magic for us, right? From the inside of the platform, we don't really care. That's a black box, it's magic. And what's going to happen is I'm going to log in, exchanging my credentials with a token. If everything happens right, what I get back is a JSON web token that has an access token, this is a cryptographic token, and a refresh token. Inside that access token, and this is a JWT, it's a standard. Inside that, we will have claims and roles, which means that I will have the ability of introspecting the token and know that a certain user is a member of a certain role, or that a certain application has a certain ability to execute a certain thing in the system. And this is something that we're doing to solve the role-based authentication. And again, this is built in, it's designed from the ground up for this system. So we have now this JWT on our side. This application now can use this access token to call everything else in the system. By passing this JWT, this access token, we can identify ourselves in a call, and we don't have the need to validate this. So in a typical security context, what we have is we log in to a central mechanism to log in. We get back some sort of token. And then every time that I now have to talk to another API inside my system, I have to send that token. And that system needs to check in a database or in another service, is this token valid? By using JWTs, we don't have that. We now have the ability of validating the JWTs locally in the target application. This is a significant advantage because we are reducing the coupling, we are reducing the dependencies that one service has over a single point of failure, which would be that application or that database that validates tokens. So we now have a foolproof cryptographic mechanism for services to receive a call that has a token in it, and we have the ability to validate that token and guarantee that it wasn't tampered with, it's properly signed, and we can trust what's inside to perform permissions and perform authorization, including role-based authentication. So As I said, unfortunately, the authorization process is a bit complex to show with just one slide, or a few slides for that matter. We do have this documentation available. So if you're welcome to consult the reference architecture documentation. We have a full page on this, and we have our mirror board that explains exactly how this works. I'm just going to sum it up. Essentially, what we have is we have a distributed mechanism where we have the ability to receive roles and membership of applications and users from an external system like an Active Directory. What this means is that I can use my Active Directory to provide or to enroll a certain user or a certain application to a group. And then what we can do in Module Loop is say, this group is equivalent to that role, which means everyone that belongs to that group is effectively a part of that role or has that role. And this is how we do the membership association. On another level, we will have the permissions. Each application will have its own permissions, and they will again bootstrap those permissions. Effectively, what happens is that we have a match between permissions and roles, so that when we receive a JWT, that JWT, the token, when we expand it, we can see the roles. Those roles will translate to permissions on a granular level for each of the applications. And this way we have a full authorization and authentication mechanism that we can scale, and that it's simple to implement from the perspective of those that are building the modules in Module Loop or extending them or doing the integration. So that was it. As usual, I'd like to thank the team today. I'm the only one here, but I'd like to thank Michael Wagner, who's been helping with the documentation. A pretty good job, and Jason Brummer and Gonçalo Garcia from the vNEXT build. These guys have been really exceptional, and we're not many. Most of us are working part-time on this, but this is progressing, so I'd like to thank this team for that effort. And again, I complain with the same ask. This is not going as fast as we would like, so if you're interested in helping, just please reach out. We have plenty of stuff to do, even if it's just writing tests for the code that we're doing. So you're welcome to help us. That's it from my side. Any questions? Good. All right.
Thank you very much. Awesome presentation. Michael Booth here from African Ender. So I understand the concept where you're using AD to provide group permissions, and then from the group permissions you use RBAC now to extend the permissions to groups. But my question is, you're using a very long method. You're taking a token, activating it, and then validating it, and then authorizing it to JWT. So I just wanted to find out from the test that you've done, how long is that authorization of the token taking? From the test that you've done.
Okay, so I'm regretting already not having the full slides. I was probably lazy on that. That's a very good question. It's not exactly like that. It's actually simpler than I made it sound. So what happens is that if you look at the security bounded context and the IAM, there's going to be some synchronization mechanisms that happen behind the scenes. So that matching between Active Directory, and by the way, Active Directory was an example. We can use another directory provider. And what's going to happen is that this IAM adapter that you're seeing is going to be able to synchronize certain groups from the external provider, in this case, Active Directory, and the roles that we have on the left side on the authentication service. So essentially, we were going to create that map. We're going to say someone who belongs in a certain group in Active Directory will also belong to a certain, or will have a certain role in this platform. So that's the matching that happens. And this is happening either on a synchronization time-based mechanism or on request. So that's how we match the roles. On the permission side, the privilege, the granular privileges, that's actually, that's also a distributed mechanism. What's happening is that each application will have its own permissions. We'll have, as an application, I will publish, for example, if I'm the transfers, I will say, I have 3 permissions, one to prepare a transfer, another to fulfill a transfer, and a third one to time out a transfer. I'm reducing to the simplicity. So I'll have these 3 permissions. When you recall this mechanism that we had with the bootstrapping. When an application starts, the application also has a bootstrapping step for the authorization. So as an application, I'm going to send a list of privileges, again, with descriptions, with proper stuff that I can put on a UI for an operator to understand. So I'm going to send that list to the central service. At that moment, an operator can go to that list, can go to a UI, to an API, obviously, but can go to a UI and, sorry, let me go back to this, can go to that UI and compose the roles. So essentially, what that operator is going to do is say, I have a certain role. I would like this role to have this permission from this application, the other permission from that application, and so on. So at this moment, we store this information. Every time an application starts, again, the same logic, the startup part, so not the bootstrap now. Every time an application starts, the application is going to ask the security services, please give me the list of roles and the mappings where my privileges are present. So essentially what I'm saying is, I don't care about all of the roles, all of the privilege. I'm the transfers. Give me the list of roles and their inner privileges for my privileges. So when I start, I will have this in memory. I will be able to cache it or store it locally, temporary, and I will have this ability. So now I know that if a certain user has a certain role, I know what that means in my privileges, in my lines of code, and I can do the authorization instantly. So now on the runtime, what happens on the runtime? I'm logging in, which means I'm going to get a token as a user or as an application. That token inside has a list of roles. That's what we typically call a claim in the JWT world. When I present this token to an application, to the transfers, for example, or to the participant's API, this token can be introspected by that API. So immediately that API, without asking anyone else, has the ability to check for the cryptographic validity of that token, making sure that it wasn't tampered with and it's valid and it hasn't expired. And it has the ability to look inside and see and ask, what are the roles that this security principle, this caller has? Once it has the roles, it can compare with the local list that it has in memory. So essentially, you can say, let me replace that now or exchange that with a list of privilege. So at this moment, I can apply my privileges and do proper authorization. So it's a complex process, but in runtime, what we're doing is we're making sure that we have interoperability. We have the necessary abstraction so that we can build something that it's not tied to Active Directory. We can do it with every single, any other system, and that it's operationally scalable and performant, so that we don't have that typical problem in distributed systems where an API receives a token and doesn't know what to do with it, right? That's what usually happens. The API picks up that token and then asks some other service that needs to be there and needs to be fast, asks, what can I do with this token? Can you tell me what this user can do? That's a tricky thing in the distributed system, because if that system is not there, or if that system is slow, everything else is going to be slow. So what we have now is the ability to do the, let's call it offline authorization and offline authentication in a very performant and scalable way and secure. Did that answer your question? That was a bit long.
Yeah, awesome design. Thank you.
Sorry,
Awesome.
I should have explained this from the start.
Thank you, Pedro. A very insightful presentation. My question, my name is John Mark. My question, I want to relate the works here on vNEXT to the first presentation, I think it was Simeon, about the community. I think one of the things that Simeon had there was in relation to the deployments. I think there is a stream around the infrastructure, AWS, Azure, and all of that. So I'm just trying to figure out where we find synergies compared in relation to what you are doing here. Yeah. Like the elements around the authentications, logging, and all of that. We know, of course, the hyperscalers, Azure, GCP, AWS have this. So my question would be, what can we pick from what you've done and you are testing to form recommendations for the streams that would be working on this infrastructure and deployment? I know there was earlier some engagement with Microsoft Azure. I don't know where that stopped or how it's progressing, but would be insightful to pick from it and then see what vNEXT, how vNEXT is being tested against what Azure or any of these other providers are putting in place. Thank you.
Okay, good. Thank you for that question. That's two or three good points in there. First one, I think we have presentations for those topics that you discussed. So people are going to explain it much better than I can. Regarding vNEXT, what we're doing is, this is something that we are doing as a continuous improvement process. We have the reference architecture and we have vNEXT. We are always updating reference architecture as we can. So as we discover something, as we learn something new, we're doing it. In terms of infrastructure, this work is being done. We don't have anything special in terms of infrastructure. Well, we have certain requirements. It needs to be portable. It needs to run from Docker containers. It needs to be deployable in simple CI/CD pipelines that we have. It needs to be deployable in any of those clouds, and it needs to be deployable locally. So when I say we don't have special requirements, that's a pretty big list of special requirements. But what I'm saying is that we're not making it special in the sense that it needs something. No, it needs containers, Linux containers. It should run anywhere where we can put Linux containers. In terms of the infrastructure communication and what we're doing in terms of or the rest of the infrastructure, it's actually the other way around. What we're hoping is that the other guys and the other work streams that are working on that can actually help us test what we have. Because they are doing, like Tom on the Kubernetes and a lot of the other guys that are working on the specific infrastructure implementations with Microsoft as well. They will have a lot more detail on this. And what we hope is that we can later provide them this code, these containers, and say, can you please run this and test it? So it's going to be the other way around. We will lean on those, on the works of those work streams to understand how we can better suit this. What we are trying is to have this approach. We're making sure that we're not depending on anything specific but containers. And by taking this approach, we expect it to just run with a bit more work, but it should run everywhere.
Thank you.
Hope to have answered. Anyone else? No more questions? All right. Let me just show the last one. This is some reading references. This is going to be in the repository, so feel free to take a look. Right, thank you. And once again, thank you to the team that's been working on this.